Hello friends, welcome back. Hearty welcome to you. In this session, let us try to solve this example together. Surface areas and volumes, mensuration for 9th or 10th grade. A circular room has a hemispherical roof. The capacity of the room is 48,510 meter cube. If the greatest height is equal to inner diameter, find the circumference of the floor. So at high level, what I see is we have been given a combination of solid. Circular means tells me that it's a cylinder, and hemispherical roof tells me that I have to add cylinder and hemisphere together. That will be the total room shape, how it will be. So that volume is given to me. But I have a condition here. If the greatest height is equal to inner diameter, that is where I have to work out so that I can find out the total volume and equate to the given numerical so that I can find out the radius. Once I find out the radius, finding out the circumference is pretty easy, because you know circumference of the floor is 2 pi r. Once we know r, we can do 2 pi r. We have been given pi equal to 22 by 7. So first let's try to understand how this diagram looks like. So a circular room has a hemispherical roof. So let us say, and we have been given that if the greatest height is equal to inner diameter is nothing but equal to 2r. So the greatest height I can go is 2 times of radius of this circular cross section. So let's try to draw this diagram. I'll try my best to just keep it simple, and let us see. So roughly this is how the figure looks like. We have been given that circular room with a hemispherical roof. We have also has been told that the total height, the greatest height is equal to 2 times of radius, and we have a hemisphere and a cylinder. Now the problem is, to calculate the volume of the cylinder, I need to know h is how much. So for that, what we will do, we will leverage the property of hemisphere, that this height is nothing but equal to the radius. So obviously we know then h is equal to 2r minus r, that is equal to r. Now we have all the information needed with us, so we can go ahead and try to find out the volume and equate it to the given value so that we can find out the radius. Let's try to summarize what we have done. A circular room has a hemispherical roof. A circular room, that's nothing but a cylinder, has a hemispherical roof. So it's a combination of cylinder and a hemisphere. The capacity of the room is 48,510 meter cube. We have been given the volume. They can also say in another way, the volume of air in the room is 48,510 meter cube. So both are same only. If the greatest height is equal to inner diameter, if this is the radius of the circle, we have been told that greatest height is 2 times of radius, but we know up to this part, so hemisphere radius is r only. We know that this or this both are equal to r. So now the height of the cylinder will be nothing but equal to 2r minus r, that is equal to r. Now let's go and find out the volume of this solid combination. First I have cylinder. Volume of cylinder is equal to, we know that pi r square h. And what's the volume of hemisphere? Volume of hemisphere equal to 2/3 into pi into r cube. So we know volume of cylinder is pi r square h, volume of hemisphere is 2/3 pi r cube. We will try to add this now, equate it to 48,510. Little bit of mathematical calculation should give us directly the value of radius. So let's do that now. So pi r square h. What is the value of h here? We know that h is nothing but equal to r. So can I say that's equal to pi r cube? So we have both the volumes now in terms of pi r cube. So my next step will be, I will write down volume of solid is equal to pi r cube, this is for cylinder, plus hemisphere, that is 2/3 pi r cube. If you take LCM and you add 1 plus 2 by 3, you will get 5 by 3. So can I say 5 by 3 pi r cube? Now, but this is given equal to 48,510. So next step will be, I'll write down 5 by 3 pi r cube is given as 48,510. So let's try to calculate what is the value of radius by that. For that, what we will do, we will say r cube equal to 48,510 into 5 by 3 will become 3 by 5, and pi will become 1 by pi, that is nothing but 7 by 22. We'll try to simplify this. We will have 5 9s are 45, 3, so then I have 35, 7, 1 will not go, 0, 5 2s are. So then after that I have 22. Directly let me try with 22. 22 4s are 88, 90, 24, 22 4s are again 88, 22 one time. So this is nothing but equal to 441 into 21, but I know 441 is nothing but 21 square. So can I write it as 21 into 21 into 21, or r cube equal to 21 cube. That's exactly 9261 if you multiply. Therefore, r equal to 21. So once we got that r equal to 21, we will go to the next step and we will write down. We have to find out the circumference of the floor. We know circumference of the floor. Circumference of floor is equal to 2 into pi into r. So 2 into 22 by 7 into r equal to 21. We'll simplify this. 7 will go 3 times. 2 22s are 44. 44 3s are 132. So we have circumference equal to 132 centimeter. So that's an interesting problem which I thought I will share with you. This is a problem from ICSE Goyal Publications 10th grade. A circular room has a hemispherical roof. The capacity of the room is 48,510 meter cube. If the greatest height is equal to inner diameter, find the circumference of the floor. So in this type of problems, we have to understand what is the relation between radius and height. If you are able to understand that and get a condition for that, then it should be pretty easy to move forward and find out the value of radius and thus circumference. So I'll catch you once again with another interesting example. Thanks for your time and support. Bye for now.